Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Multiples are just a numbers times table, so to write the multiples of 11, we're just going to do 1 times 11, 2 times 11, 3 times 11, 4 times 11, and 5 times 11. Now, we're not going to do any more because it says it just wants the first 5. So I'm just going to write those down in a list with commas, separating them. So to simplify 10 to 22 to 26, I'm going to have to find something that I can divide the 10, the 22 and the 26 by. The biggest number I can do that for is 2. So if you look, 10 can be divided by 5 but nothing else can, 22 can be divided by 11 but nothing else can, and 26 by 13 but nothing else can. The only thing we can divide all of them by is 2. So that will be 5 to 11 to 13. So the answer is 5 to 11 to 13. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white, so it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91, and that's our probability, 25 over 91. Be careful when it's a total, you must include all of the outcomes, so red, white and other. Instead of doing 0.43 times 16, what I'm going to do is I'm going to do 43 times 16. So I'm just going to get rid of the decimal and just change it to 43. But I've got to remember what I've done. So how have I managed to do that? Well, I've times it by 100, and that'll be important at the end. And to do 43 times 16, there are loads and loads of different methods. Just pick whichever method you enjoy doing or that you find easiest. I'm going to do the grid method, but it by no means is the best method. It's just the one I'm choosing to do. So 43 is 43 and 16 is 10 and 6. So 40 times 10 is 400, 40 times 6 is 240, 10 times 3 is 30, and 3 times 6 is 18. Then I'm just going to add them all together. So 400 plus 240 plus 30 plus 18. And when you add those all together, you get 688. Okay. Now, the problem is that obviously this is not going to equal 688. What we've done though is we've times it by 100. So to find the answer, all we need to do is divide this, undo that times by 100, so divide it by 100. When we divide that by 100, we get 6.88. So we start off by working out what 100% of 240 is. Well, that's obviously going to be 240. And a nice easy one to start off with is 10%. We're trying to get to 21%, so 10% is always a good one to start with. So we divide by 10, which would be 24. And because we try to get to 21%, we'll need to find out what 1% is. And 1%, we just divide the 10% by 10 again, so it would be 2.4. And then we need to find out what 20% is. And 20%, we just double the 10%, so it would be 48. And so 21% is this plus this, because 1 plus 20 is 21. So we add these together, so 2.4 plus 48. Probably don't need to do this formally. Probably do this in our heads. So 50.4, but it says to increase 240 by that amount. So we need to get 240. We need to add the 50.4. Probably, again, don't need to show the working out for this. We can do this in our heads, but it's a bit easier to see what we're doing. So the answer would be 290.4. So we're going to start by doing a multiplication grid. And we're multiplying the x minus 11, so x and minus 11, by the x minus 3, so x and then minus 3. So x times x is x squared, x times minus 11 is minus 11x, x times minus 3 is minus 3x, and minus 3 times minus 11 is positive 33, because 2 minuses make a plus. Put the terms together, and you'll notice here that we can simplify. So we've got two x terms, so we can collect the x terms, and that will give us x squared minus 14x plus 33. So our answer is x squared minus 14x plus 33. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now, it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55. And it's going to be 0.55 times the amount of days. Well, it says the amount of days is x. So it's going to be 0.55x. Then it says that there's just a one-off cost of £15. So you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2, times 5 is going to be 10. So our answer is 10. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which would be 9 to the power of 22. So our answer is 9 to the power of 22. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And I'm just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. With these questions, what we need to do is write down what we're given in the question. So it says that the car accelerates at 6 meters per second squared. So we got the acceleration, which is 6 meters per second squared. And I'm using the same letters as it has in the question here. It says for 21 seconds, so we've got the time, which is here. So the time is 21 seconds. Now, there is also something else it gives us, because it says from rest. So the initial velocity is going to be 0. And it asks us to find the final velocity. So we're looking for what v is. So we're looking to see which of the three formulae at the top involve an A, a T, a U, and a V. So it's not going to be this one because this has an S. It's not going to be this one because this has an S. It's going to be the top one. So what we do is we write down the top one. V equals U plus AT. And we're looking for V, so I'm going to keep V as a V. U is 0. Plus A, which is 6, times T, which is 21. 6 times 21 is 126. Obviously 0 plus 126 is just 126. The units are meters and seconds throughout, so it's going to be 126 meters per second. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4, because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7 over 4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a times sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this, because we can divide top and bottom by 4, so that would be 23 over 7. And then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2 over 7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels, but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. There's 2 parts to this power. I'm just going to do it a bit bigger so we can see. We've got the negative here, and the negative will mean that we will find the reciprocal, and we've got this 3 here, which is just what the power will be. So how do we find the reciprocal? Well, if you think about the number 10, if you had to write that as a fraction, you would write it as 10 over 1. And so to find the reciprocal of it, we're just going to flip that fraction. So this will now become 1 over 10. We haven't dealt with that cube yet. So we're going to cube top and bottom with that fraction. Well, it's not going to do anything to the top because 1 cubed is just 1. But the bottom will turn into 1,000. So it's going to be 1 over 1,000. We're going to start by focusing on the A and B, which is 8 and 16, so in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle, so the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. So we're going to first of all realise that this is a right angle triangle and we've got 2 lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, CA, TOA. And we are just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals root 3 over 2. You need to know from memory that sine 60 is root 3 over 2. And notice here that the x therefore is going to equal 60. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines and label the new shape B. We're going to write this out again just to give us a bit more space. So we've got S equals 4 minus 13t over t minus 5. We're going to get our lines in. Okay, so the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with s brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be the way around, so I could have 5s plus 4 over 13 plus s, or anything like that. So if the area of the rectangle is 10 and one of the lengths is root 75, to find the other length, we do the area divided by the length given, and that will work out what the other length is. Root 75 though is something that can be simplified, so let's simplify that. And it's root 25 root 3, so it's 5 root 3. So this equals 10 over 5 root 3. Now notice top and bottom can be simplified, so that becomes 2 over root 3. And we're asked to rationalise the denominator, so we're going to times this by root 3 over root 3. And so we end up with 2 root 3 over 3. So our answer is 2 root 3 over 3. So we're going to start off just by writing down the quadratic. And what we're going to do is we're going to move everything onto the right hand side apart from the x squared. So we're going to take away 11x and we're going to add 3 both sides. So we're going to end up with x squared equals effectively 3 minus 11x. Then we're going to square root both sides. And so we have x equals the square root of 3 minus 11x. And that's the way to come up with an iteration formula, is to isolate the x squared of a quadratic and then square root it, and then you've got this kind of x equals, and it involves the square root and the 3 and the minus x, 11x. And you can see that that is option C with the choices. So the answer is just C. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.5 4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x, and then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.